Hey, everybody. Welcome back to yet another Prefect Live. We're here with the one, the only Kevin Kho. What's up, Kevin?
What's up? Not much. It's just been busy after launch week.
Yeah, super busy. And let's not even get into it yet. Maybe we can do a little banter, little how's the what's your review of the launch week community initiatives? How do you like them? What do you feel? So I'll recap them for you. We did Pizza Patrol, and we've got Club 42, and we got Marvin's Challenge, the hackathon. How you feeling?
Yeah, I am very disappointed in our viewers for not joining Marvin's challenge. I was expecting a lot more participation. But
Well,
I am also yeah, good.
I was gonna say I love Noah Holmes' submission.
Yeah, Noah Home had an insane submission.
Yeah,
Look at it in the Slack channel if you haven't yet. Under show us what you got. Um, I know five people who got pizzas, and they were pretty amazed that they were all like local pizzerias and non-chains. Like, people were just expecting like Domino's to show up.
right.
Well, no one was really expecting a pizza to begin with, and they're more they're more surprised when it's like, oh shit, it's actually real, you know?
Right. Yeah, they couldn't believe they put their address in and a pizza showed up. But if you know five people, Kevin, I saw that map. I don't know if you saw that map, by the way, but I saw that map, and I think they were all within a block of your house. All those pizza deliveries.
I didn't get pizza myself because I don't know if there are any non-prefect employees, but we have that $25 stipend for food every day, and like I went to pick up that food and I wanted to make it back in time to order my pizza also, but I just couldn't finish. Like I didn't make it back in time.
Yeah, and that's that. So we do have a $25 a day lunch stipend every day for prefect employees, which that's a great call out for hiring. If anyone's interested in joining prefect, you get some sick bennies. What's your go to, like? What'd you get on the last Monday? What's your go to order?
That was my birthday. So I ended up getting, so we have the lunch 25 and we have the birthday 25. So I had 50 and then I spent my own money also. So I got like $75 of Filipino food.
Nice. I
Yeah.
was gonna
Yeah.
say, I mean, that's a lot of Filipino food. It's a ton of food.
Yeah, that's a lot of food. So it
Yeah,
lasted 3 days. Yeah.
nice.
Yeah.
That's
I would not have space for that pizza.
no, and happy birthday, by the way. Happy birthday.
Thank you. Thank you. Of course.
Nice.
I mean, we had the whole week of celebration last week for my birthday,
That's what it was for,
right?
actually. I don't know if you
Yeah,
guys
yeah,
noticed,
yeah.
but launch week was for Kevin's birthday. Just a
Exactly.
funny little thing. Cool. Well,
Yeah.
yeah, it's a great week last week. We're here again with Prefect Live. Let's get into it. We're going to validate some data, and I think I know what that means, but I'm interested to see what are we doing. Zoom in one for us, if you wouldn't mind.
Yeah,
Give her
that's
one. Give her a single
oops,
zoom.
wrong window. Okay, here,
There
here
you
we
go.
go.
Perfect.
Okay. So yeah, hey everyone. Today we're gonna be talking about data validation. So if you haven't seen this yet, yours truly, I actually talked about data validation in last year's PyCon. I talked about large scale data validation.
On a live
Unrel-
stream, he's bringing up a video of himself.
yeah,
Nice.
unrelated to prefect, and also I am also an O'Reilly instructor
Wow.
for testing data pipelines with data validation, unrelated to prefect as well. They found me because of my PyCon presentation, and then they reached out and said, "Hey, would you be interested in doing a course?" So I did. Um,
Very legit. Very
so
legit.
thank you. So what we're doing is we're in that presentation, I used data validation on Spark or Dask, and now today the end goal is we're gonna like use the Dask executor of Prefect One. Well, first we'll do it with Prefect One. We're gonna use the Dask executor to run like parallel validation, and then if that's successful, we're gonna bring it to Orion also and see how it translates. So for today, what we're gonna do is we're just gonna give a brief overview of validation, and then just go over some like what the current frameworks are, and then we'll use data validation on a data set, and then we'll bring it to Prefect One, make a flow. I'll show you that mapping for large scale using Dask, and then we'll bring it to Orion.
when we can let's
So
bring it to
yeah,
Prefect 2.0. Let's control F on the hotspot.
yeah, we'll get there. We'll get there. We'll get there. So for those who are not familiar, data validation is basically having data quality checks in place. So if you have data that's already in your system and you have pipelines built off of it, you want to make sure that new data in the future fulfills the same profile as this data set. Otherwise, you can have wonky dashboards, you can have wonky machine learning predictions. Stuff can break in worst case scenarios. So validation is actually pretty related to prefect in that we want to make sure that pipelines run robustly and don't have any downtime.
What's
So
Kevin? What's an
yeah.
example of why you might need data validation? So you just said like things can break. What's an example of is like a malformed packet, right? To go back to my or a drop packet to go
Uh,
back to my UDP days.
yeah. Let's open this video because I
Yeah,
actually made a fictitious company here called
yeah.
Food Sloth. And Food Sloth does a delivery, right?
Mhm.
And the concern, let's say there's demand pricing, like you're like Uber or Lyft, like that kind of place, and you're updating a price every so often, then you're concerned that, hey, what if the price is too high or too low, right? And so there is some criteria for the price. Like there is some criteria that this price has to be within the certain range, right? And then that criteria is probably location specific also, right? Like where you're at in the middle of nowhere. No, just joking.
It's true.
where,
No,
where
it's
you're
true.
where you're at, prices might probably be cheaper and your criteria might be lower. And then if you're in somewhere like California, then your criteria for prices, your range of acceptable values is higher. So you use data validation could be used there. You validate before you actually push your predictions into production. You can also validate, like very common validations are like, hey, let's, like what you said, like what if the data is malformed, so you can check, hey, what percent of the data is null, like should it be null, or should we just
Right.
like not run the program at all if it's null, because that indicates like corrupt data that will corrupt downstream stuff as well. You can also think of like like if you have a field that is like, let's say, male female, or actually let's not be, let's be more let's I mean, yeah, let's say you have male female or you have
Hmm.
other stuff in there, you want to validate that, hey, it's with the acceptable values.
Hmm.
Then you can check over those, like, hey,
Oh,
this
right.
is,
Okay.
I'm within, like I don't have any other, like other value, right?
Right. Right.
um
Like zeros or something like that. No, that makes sense. And I guess uh, one other example is just a load not happening too, right? So I think we talked about malform, but maybe just data not showing up, which I think happens a lot.
yeah. So if you had some, that would be a more like custom check, like you're saying,
Hmm.
like, hey, what's the value today,
Yeah.
and you're gonna like see if that date is present within your like source tables. Like that would be like a custom check that you would write. The standard checks are very like, within this range, this the max, this the
Hmm.
min, like that kind of thing. So current the validation ecosystem right now, well, for Python specifically, we are partners with Great Expectation. Like they are a verified task in our task library right now. So people are very familiar with Great Expectations. I'll be talking about them less today, so I can like show another library in Pandera.
Hmm.
But Great Expectations, what makes them really sexy is this data documentation. So you run your profile on your data set and it generates these like maybe we can even open this. Oh no, not really. It generates this like data documentation that you can
Hmm.
then pass in your team, and then it you can also filter by failed validations, and you can, like, this is kind of like, so if you think of data validation as like the contract for which your data needs to uphold, like it's like unit test for data, this is the
Yep.
contract that your data needs to uphold. Then you can easily share this and say like, hey, this data is off, and this thing seems wrong or something like that. So the, very, I mean, they have a lot of robust features, But there's also a lot of learning comparatively that you have to do in order to get these data documents. But the task actually is really nice. Just in case nobody, I mean, just in case no, like someone has is not familiar with it, what the
Mhm.
prefect task lets you do is generate this as an artifact in the prefect UI. So you run your validation, and then you get that report present in your prefect UI. So that's great expectations. And then we'll look at Pandera, which is mainly for Pandas base. So Great Expectations is available on Pandas Spark and SQL. Like on the database, you can run your validations on the database. Whereas like something like this Pandas, you actually have to load the data in Python and then use this on that data set in
Mhm.
memory, right? Whereas like Great Expectations can go inside the database and run it through SQL Alchemy. Uh, Pandera changed. I mean, not changed. They actually like added support for this Koalas, which is a Spark API, moded as the DAS API. So
Mhm.
now you have validation across Spark, Pandas, and Dask, right? Um, so Pandera is the one I showed in my last PyCon presentation and the one that I'm gonna show today. In general, it's very lightweight. There's no documentation like that. It's just very non-invasive. You just apply it with a couple decorators. So we're gonna use this in our prefect in our code that will eventually bring to prefect, and I'll explain this more later.
I got a quick question. You
Yeah.
said that this is a library that can handle data validation in Spark. Why would someone write, unless I guess they're using PySpark exclusively, like why is someone writing data validation in Python for Spark? Do you know the answer
Oh,
to that?
okay. Yeah. So I think the question here is because like Spark traditionally is written in Scala, right? And there's this
Yep.
conception that, hey, like the Scala code will be two to three times, maybe two times faster than Python code, right? But I mean, realistically, I think if you look at the Databricks published this, whereas like if you look at the profile of like who the Spark, I mean, what language people use to interact with Spark, I think Python clear number one. It's like in
Interesting.
Python plus SQL will be like 70% maybe, and
Interesting.
that Scala side is like 30%. So it's just because of the sheer volume of people who know Python versus Scala, right? That you, I mean, if you need some heavy optimization, then it makes sense to invest. But then, um, like this, right? Like using koalas, stuff like koalas, right? Where is like this koalas. Now you can kind of have it. It doesn't really work, but you can kind of have like reusable Python code or functions between your pandas and Spark code. You just have to like massage it, but to get it to work. But that's not even an option if you're Scala, if you're using Spark and Scala and
Right.
pandas Python, right? So
So I was just contributing to the misconception. That
no,
was
no,
on me.
no, no,
Yeah.
no. This is true though. It
Yeah.
was true, but I think Databricks, the company behind Spark, has been making a lot. They have this whole roadmap that they called Project Zen, right? And this Project Zen is basically improving Python for Spark users. And this is
Got it.
this whole
Interesting.
initiative, and there's like three or four pillars of this, right? To make the interface for PySpark friendlier for like really native, like for Python developers. Like for example, some of the errors that you would get are all like JVM errors. So now they make it like, how do we make it easier to like actually surface Python errors instead? Stuff
Right.
like that. Limit the traceback. Yeah.
Interesting.
And
I did not know about this.
yeah,
This is really cool, but it makes sense for the market. That I think Databricks probably saw some competition from Dask and is then I think trying to react to that in some way.
yeah. Like definitely like PySpark is a first class interface. I mean,
Yeah.
there are use cases where it won't be as fast. Probably. Oh, here, look at this. 68% of notebook commands in Databricks are in Python,
Wow.
right?
Yeah. You were right. You were right.
Yeah.
You know what's interesting
Yeah.
about PySpark is that from when I've worked with it in the past, it feels almost like, at least in the examples I was working with, writing SQL a little bit. That was what was interesting about PySpark, is I think a lot of people will just use that to then write SQL somehow into Databricks.
Yeah, for sure. Their SQL interface is definitely a first
Mm-hmm.
class, and like if you use if you have a choice between using like the Python interface versus the SQL interface, SQL will be faster, I think,
Mm-hmm.
because that goes directly to Scala, right? Because like SQL is like an abstraction that then
Right,
it
right,
doesn't have to run through the Python. Yeah,
right. Yeah, that makes sense. That makes sense.
yeah.
Cool.
So the next is Soda SQL, which is also a task in the task library. Soda SQL is you run data validation directly on your data warehouse. So we have like this is a community contributed task by Alessandro,
Shout out
who contributes
Alessandro. Shout out
who
Alessandro.
contributes so many of the tasks.
Yeah,
Um, you probably see his face here also. Like there he is. There.
yeah.
So what you do is you have like this kind of spec, and then this runs on some regular interval across your database, and this is like very like, hey, what's the row count, what's the missing count, missing percentage, stuff like that. So normally you're writing stuff in SQL, um, or
But
some or what they have built in.
it has to be YAML though. Like it's a YAML file.
I believe they started out as YAML, but I think like recent I saw recently that they have like
Oh, okay,
this like yeah.
interesting.
So I haven't tried it, but I guess they will have some sort of like data frame kind of interface also.
Got it.
And then the other question that I get when I give this training with O'Reilly is like, hey, what's the difference between validation here and like that type of validation when you have like a machine learning model and then the performance is decaying over time
Mhm.
and it's not really relevant anymore, right? So that's another kind of validation. It's just a special validation, right? That's called model drift, right? So evidently AI is an open source project for this monitoring for that drift, right? So what you do is you run like a batch job and you kind of compare, hey, how much is like, let's say my model is predicting that um like uh like I have a bunch of like, let's say, balls, and like it's like, hey, 50% of the like the distribution of like my predictions might be changing over time. Like
Yeah,
when I started, maybe I was predicting 50% red, and over time I'm predicting 30% red. It could be right that the state of the world has changed, but it's also something that like you don't really know that, right? You have to like look into it.
it can be a bit
And it,
unnerving. It can be a bit unnerving when your model is drifted so significantly, right? Because that's almost a 50% change.
yeah, and it does happen when the state of the world does change. Like I know, um I remember when I started as a data scientist, the first presentation I saw about model drift, they were using sensors in cars, right? And they would predict like do some like predictive maintenance, like, oh, this part is gonna break, so let's replace it ahead of time. And then I think something happened that they had a program that rolled out that made the maintenance better. So now the model is not applicable anymore, right? Or
Hmm.
like maybe like for example, maybe they rolled out like a fleet in like place with snow and that deteriorates harder. Your model's not
Right.
applicable anymore.
That's
Yeah,
a
stuff like
really
that.
really great example too, because in a scenario like that, that could be a huge exterior force that you don't account for in your model. So really interesting. Good way to monitor
Exactly.
that. Yeah.
Yeah. So evidently that AI is like you make this is relatively new, and like I gave a I presented this in a one of those meetups, the MLOps meetups. I had a section on this. So what you do is you have same thing as it's an in between. Like you get some sexy reports as well. Maybe I can show what the reports look like. Um, not really. So the report will look like this. You get a report like this, and it shows you, hey, these are all the things that are changing.
Yeah.
Hey, these are your predictors, and this is how the distribution is changing over time.
And
So
look
evidently
at
that
this variety of chart, by the way. I mean, we've got scatter plot, bar chart, I think a tree map or a heat map of some sort. Fascinating.
that's just like if they're a classification you're here, and if you're
Yeah,
like
right.
a regression you're here. That's really
Yeah,
good.
nice.
So yeah, so you can do model performance with them. So target drift is the one I talk about, like the state of the world is changing.
Mm-hmm.
Um, Model performance, I think, is like if you collect new data in the future, you can compare. Data drift, though, is the one that's like I don't even know anything about the results. All I see is that some distributions are changing, right? So this is also good to check out. Um, and then, so now we're done with the ecosystem. Um, and what we're gonna do is we're gonna apply Pandera on our data set.
And I will point out too one last thing. Last time Kevin was on PrefectLive, one of the comments that we got on the YouTube recording was, "I love the way he organizes his code," and this is just another example of well organized code. A question real quick from the chat: is there any alerting functionality there in Evidently.ai?
I'd like to tell you that Prefect can provide the functionality for you. But how it works how it works though is that you compare and you get a JSON report, and then you parse that. I don't know if they have it natively, but what you would do is you would parse that JSON report,
Mm-hmm.
and then you'd find the metrics that you're concerned about. And then if they are too high, then you'd send if they're part of your Prefect flow, then you'd send the alert. I don't
And,
think they have it natively yet. They're relatively new, like a
and so
year or something.
it's just like a point in time JSON report, and you just take the deltas, and then is that what you're
Exactly,
flagging? Yeah.
exactly.
Okay.
Yeah,
That
you
makes
get some metric, and then
yeah.
like it has a bunch of metrics, like how many like features have like drifted distributions, and then you just use that, for example.
Yeah,
Um,
and that's it. By the way, from frequent chat contributor Henning, and he says plots are nice, JSON is practical, which is true. So
that's very very true, because like I was like playing around with this, and I generated the report, and I committed it to my Git repo, and the report was like 10 megabytes, and it like killed my repo, so like I had to like it made all this like delta checking like so slow. So like for sure, like if you have that report in a notebook, it occupies so much space that it's not practical. So yeah, I agree that JSON is way more practical. But we don't have this yet, but I'm sure like hey, that report would look nice as an artifact in the Prefect UI as well,
mhm.
right? Yeah. So we're gonna go over our sample data set. Um, this is just artificial data that gives us a bunch of like cases to uh, that where we can use different types of validations. So I have this baseline parquet and new data.parquet. I didn't upload it yet, but I will upload the repo. So for a quick reference, I'm just gonna do baseline.head. And your comment about code quality, maybe we're speaking too soon here. So I have my baseline data, and I have
Mhm.
8 features. The category will just be A or B. And then feature one, feature two is just a uniform from 0 to 1 and 3 to 4. And then feature three will be in between feature one and feature two. So this is like the first time we're going to see like a cross column kind of feature. And then feature four is a distribution, mean zero, standard deviation one.
So what could sorry to interrupt you there. What would be an example,
Yeah.
and you might not know the answer to this, but of feature three, where it's always going to be between feature one? I guess it's like a min max situation with feature one and feature two of some kind of measurement, maybe.
Like what's a real use case for that?
Yeah. I'm just
Hmm.
curious for feature three. To me, I guess it could be min max and then average was probably like if you're taking multiple readings, right? Like for
Yeah,
example,
yeah,
let's
yeah.
say temperature, right?
Yeah, that would be valid, for sure. Like, yeah, like definitely like feature three should not be exceeding like one of
Right,
those.
right.
That's a good one. Like normally you're in some kind of like range that you're monitoring, and this the
Yeah.
high and the low, and you want to make sure that this is in the middle,
And then
right?
here's actually a good example for our viewers. Is did some work with a company manufacturing drugs, and they use these vessels, and they put them inside of things at certain pressures and temperatures, and so they would do a start pressure temperature reading, than an end pressure temperature reading. So I think that would be an interesting example of that. Sorry to
Yeah.
interrupt.
No, 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 that's fine. All good. And then feature four is normal distribution. So the mean will be zero, standard deviation one. Feature five is a string, and the starting letter will always be K.
Hmm.
And features six, seven, and eight are more interesting. What these guys are dependent on the category. So if your category is A, you have a certain range of values, and if your category is B, then you have another range, right? So feature six is actually two normal distributions depending on the category. Feature seven is there's three values here, C1, C2, C3. But if you are like A, then you can only do like C2 and C3. And
Mm-hmm.
if you do like B, you can only do C1, C2. So it's like on the column level, you're gonna think as long as it's C1, C2, C3, it's fine. But it actually depends on the category. And the last one is feature eight. The starting letter here has to be match the starting letter here. So
I'm
yeah.
really interested to see how we're going to get this in the code, but let's do it. All these the data spec.
What oh, you mean like how to validate that?
Yeah, I'm really interested.
Yeah, okay. So we'll have we're just gonna do some basic plot. I'll just copy this. We're just gonna do some basic plotting just to kind of get picture what this data looks like. Oh no, I need the like matplotlib inline or something. Let me. Is it like this? Matplotlib. Okay, there we go. So we have this is feature one, two, and three. So feature one below, feature two
Mhm.
here, feature three here. Now the we loaded two files earlier. Baseline is the one that follows the spec. New data is corrupted. So we're gonna see how it is corrupted. And to plot it, what we're gonna do is we're gonna just make this like just get all the points because like this time series is I mean this series is too long. If I just plot it, it's not really gonna like if I just change this, you're not gonna really see um the points where it's off. So we need to make it more obvious. So what we're gonna do is we're gonna filter for these rows that are actually not fulfilling the criteria, and then from there, what we're gonna do is just get the points around them. You don't have to worry about this too much. The important
Mhm.
part is the plot here. So in our new data, right, we have feature three that's above feature two. So this is wrong. We have some feature one that is too low. We have some feature two that is also too low here in these orange bars, right? So we want to capture this. Feature four, I'm just gonna take out some warnings first, and then we're gonna just plot them, and you'll see that there's a change in distribution. The blue one is the baseline, and our new data is this orange one.
Cool.
Yeah. The feature five is very not so exciting to plot. It's just a count. So we have
Boring.
every yeah everything starts in with K in feature five, and then in
Yeah.
feature for the new data, there's like 10 records that start with the letter P.
Right.
Feature six, seven, and eight. This is where I said things get interesting. So feature six is we have two distributions, right? Depending on the category.
Hmm.
And in the, I guess I don't have, do I not have the new date? I'll just use this and let's see what the new data looks like. I think the new data might, I forget now, but I think the new data might be like, some, what one distribution instead of two, we'll find out.
Hmm. Yeah.
Uh, that's gonna be hard. No, no, just joking. um, okay, and then feature seven is the one where I'm like saying that the limit is it has to be between C1 C2, and then for category B, it can be C2 or C3. If you look at this for the new data, what you're gonna find is B violates because it has C1 entries that are C1.
Right.
And then the last one is this one is just the letter has to match the category A with if you look at baseline dot head, this record here just needs, if this is letter B, if this has to start with letter B. That's pretty
Mhm.
much it. So okay, with that, let's get started with Pandera.
So that
And
was
we're
what
yeah.
I might call manual data validation, right? Just like brute force,
Yeah. I mean,
visual.
so if it's like you're training a machine learning model, right? It's
Mhm.
like, hey, training on stuff I know, and then I'm gonna predict stuff I don't.
Right.
So validation is the same way. You have profiling, and then you apply that profile. So the profiling, Great Expectations has its own profiler, but like Pandera doesn't have its own profiler. So normally you run a profiler, and that gives you a guide of like what rules to put in, and then you see which are important for you, and
Mhm.
then you apply it, right? Um, so let's look at Pandera. I want to cover the design philosophy here because it's pretty interesting. Um, so there's this GitHub issue. Oh man, this is ugly. I'll just
Mhm.
read this. So there's this GitHub issue, and the author said that there are three design philosophies to Pandera. Number one, minimize the number of classes in the public facing API, so it should be non-invasive. Number two, the schema should resemble the thing that's being validated. So if you're doing like a pandas data frame, the validator should kind of resemble the pandas data frame. If you're doing just like one column, which is a series in pandas, then it should resemble that, right?
Right.
And then it wants to be non-invasive but expressive, right? So let's start with this. What we're gonna do is first I, I will import Pandera and think. Oh, this is Markdown. By the way, everyone, I just want to let you all know that I have a new keyboard today.
Oh,
All my parts came in yesterday. I mean,
Kevin,
for this one.
do you need a white prefect P key?
Yeah.
I
I now have a keyboard that can take it, right?
Yeah, I have a white one here. We usually do black ones, but I have a white one, so I'll ship it to you. Anyways, that looks great, and I can hear it though too. I can definitely hear it. Looks sounds
Oh, you
nice.
can hear it.
Yeah, it's nice.
Um, so the we will check the feature one and feature two, and what we're gonna do is create this Pandera column. This is the type of the column. So something very common with pandas is like you read in a CSV, and uh, because the CSV doesn't hold schema, you're going to infer schema, and then the schema inference is wrong. So this is actually Pandera because it's designed for pandas. Now you can coerce this data type. So if this was not a float, we could make it a float. And then we provide our checks. So we say, check that this is greater than 0 and less than 1. But of course, this can be compressed. Hey, there's this check that it's in this certain range, right? So, and then you can say feature one dot check validate, feature two dot check validate, right? Oh, okay. So what does validating do? It didn't do anything. It just returned the same data frame. But what we can do is we can validate the new data so we can see what happens when it actually fails, right? So we can say feature one dot check validate new data, and we get this schema error. It's very ugly. But the schema error says, hey, these are the failure cases, that did not match your validation criteria. So you said that they have to be greater than 0, and you have these negative numbers. So that's the use of using a validation framework. Like you could make these asserts yourself, but at some point, like the reporting is hard. Right now, we have all the
Right.
indices associated with it, so it's the same thing as prefect. Like you could make your own naive orchestrator. At some point, it's gonna be like more work to maintain that thing. So you may want to just use a validation framework instead. But of course, what I just showed you. is on the column level over here. So I'm gonna take this out. It's just kind of ugly. And then I am going to make a validator for the data frame level, right? So here we have our data frame schema, and this is what we were saying earlier. This should be isomorphic to the like object that you are validating, and then this thing can take in columns. So here we're just checking the very low hanging fruit. Feature one we know has to be between these values. Feature two, we are passing in this previously defined column just to show that hey, you can do that. Feature five is just hey, the string has to start with this, and then I'm saying coerce equals true to make sure that it's a string.
I like this string starts with. That's funny.
Why
Well,
is it funny?
that's specific to this framework, correct?
I
To
would say a lot have their own. I mean, I don't know what how they listed, but a lot have their
yeah,
own like string must start with.
got it.
Um, and feature 10 does not exist. But what we can do is we can make the schema and we can say, hey, required equals false. So it's not even checked. And then we say validate and we're good, right? Um, so but then this is just the syntax that I gave you that I showed you here is just for an individual column. So how do we tackle feature three, which has to be in between feature one and feature two? And the answer to that is you have to make a um you have to so a while ago we used the first argument here is actually columns. And what we have to do is we have to make this new argument called checks. And this check can take in the data frame. So we have a lambda on the data frame level, and then we apply our check, and then we name it, right? And now you can say wide schema dot validate baseline, and now our baseline passes. So data frame wide checks have to go in here, and column wide checks go in here. This one though is applied per row, so it's obviously will be slower. So if you can express your check in a just like in a column, it's much easier than if you had to do this, right? Because this is like applied per row and very slow on pandas. But for panda size data, it's normally fine. Um, and the next thing I'm gonna do is we're gonna apply this wide schema to our new data. Dot validate new data. And of course, we're gonna run into errors. But let's look at the error. The error tells us that hey, you said that column one has to be greater than zero, and you have these negative numbers. And this is obviously we don't want this because this is only reporting on the first validator that failed, right? But what we want is that we actually have check one, check two, check three, and we didn't reach here because it already failed here. So if we want to run everything, what we just say is lazy equals true, and this will return the broader report. Um, this is really ugly. Let's try calling this dot data. Try it's giving us the code to do this. So we say wide schema instead, and here we say new data. And this schema errors is not defined. Uh, I I I guess we can just do this. No, that didn't work. Let me okay, let me take a look here. Oh, I see. I see the import. Okay, there we go. So now we have data. I'm gonna print this instead, and I think it's a data frame, so it should be able to give me. There we go. Oh, I want the failure cases, not the data. I want to print this. So here now we get that like complete check. Hey, this check failed, and this was the failure case. You're gonna find that like look, it said that hey, you failed feature three has to be in between this, but the failure case is like a string, and this is because like when you apply your own custom check, it doesn't know like how to interpret that when you reach here and you're looking at the errors. So that's just a bit of a downside because it's a bit custom. But
Mhm.
other than that, like it's like you get that full report. So I'm gonna breeze through the next couple ones just because we have to get to prefect. but so here is the
Not
check
even
for
necessary, by the way. Not even necessary.
you mean prefect's not necessary?
Yeah, well, we can just. This is interesting. We can go as far as we get.
Oh, okay, okay. So here we have a like we have that normal distribution for let me see if chat is saying anything. Uh
No, we got some keycap comments.
okay, okay,
Yeah,
okay.
yeah. No,
Okay.
nothing serious. If I guess yeah, Chad. If you want to see how you would productionize this with Prefect, we'd love to hear it in chat.
Yeah.
But we'll keep going at this pace.
Yeah. Or you can ask me in Slack. I'm there every day. So I'll see you there. So we have our normal our test for normal. So Pandera integrates with SciPy. So now you can pass this normal test from SciPy
Mhm.
into Pandera so that you can test that hey, this feature 4 has to be normal. And we do that normal test and we just say, hey, this p-value has to pass this threshold level of significance to make sure that it's normal, right? And then we can apply that here with our data frame schema. We apply it on a column, and this column is taking in the check for normality now, right? And I have another syntax here, which is a just to show that you can have like column level like aggregate checks. So all the checks that I've showed were like on a per row basis. So if you want to do something like aggregate on a you know bigger like on the mean or like on a group by, then you'd have to do something like this. So this this one is like just to show you, this one will unfortunately work on our new data because if you remember, oh, it didn't. Our new data is normal though. This guy that we have a different mean. I'm gonna take this mean out just so we can test for normality.
Mhm.
And it's working on the new data. And that's expected because it was normal as well. It just had a different mean and standard deviation. So something like this, you have to couple them together, like check the mean and the standard deviation along with the fact that it is normal, right? You just have to do it.
Right.
Um,
Another interesting comment from Anna too in chat. This really shows that you can't do everything in SQL. Imagine trying to do similar validation in a SQL query, which is a really great point.
Yeah, definitely. And I'd like to say that it's like it's also hard to do it in Spark just because it's really expensive. I mean, it's not hard, but it's like so unnecessarily expensive, right? Like you have data living across multiple machines, and
Right.
now I want to get a distribution of this data that lives across multiple machines. So you have to be mindful also that like the thing that you're doing makes sense. So normally, like if it's like that, you have to sample in some way and hope like some representative sample.
Well, I feel like though data validation on sampled data is it worth doing anyways, right? I mean, I guess so, but you're still at if you're doing this to check
Uh,
for
uh,
like you see what I'm saying across all your data,
yeah, yeah,
it
yeah,
just makes no sense.
yeah. For profiling, you
Hmm.
can
Right.
sample, but if you're doing that like on the field check, like yeah, you just yeah, you I mean, profiles should like if because I mean it's also not necessarily practical to like with big data normally you have like tolerances anyway, like you say like get me the mean, like not mean but like the median within like this certain
Right.
percentile bound, just so that you relax the constraint and you can get spend less compute on it. So it's just the same, like you have to just be mindful of the bounds that you're willing to accept.
Hmm.
um so let's now we get to the interesting part, feature 6, 7, and 8. remember that these guys change depending on the category. So these ones take a bit of creativity in order to get with Pandera. So the first one was this normal check. The normal check, we have to basically create two normal checks. So I'm gonna make the first one. This one takes an A, and I'm gonna make a second one by copying this with a deep copy, and this one is changed to B. And now that I have this, I can um, validate same thing on the by passing in, hey, feature 6 has to pass normal check 1 and normal check 2. Normal check 1 will get it all the A guys, make sure they're normal. Normal check 2 will get all the B guys and then make sure they're normal. So this one is, I believe this will also pass for our new data, because the new data is both normal. It's just like they have different means and standard deviation. Um, Feature 7 is also, so this one takes a bit of creativity. So just to remind you, we have category A, which can only be C1 and C2, and B, that can be C2, C3. But if you validate on the column level, then you're going to say like, hey, it has to be within C1, C2, C3. So this one, what this, I mean, I won't say it took a while to figure out, but like it took some effort to figure out. What you have to do is you have to create like a dictionary, and the dictionary contains the acceptable values, right? So A can take in these two, B can take in these two. And then now you can say for every row, check that dictionary using the row category and check if this value is in this dictionary. And then you apply it for every row. So a bit expensive, really, because you have to apply it on every row, right? And the last one is just the like, hey, the last letter of the column, the last letter, I mean the first column here has to match the category. That one is just, you just the same thing element wise. Actually, so this one is a good example. This is not element wise, this is a good example where I'm piggybacking off of Pandas' like vectorized operation, so that I can just do it in one go and then compare this column. This is a vectorized operation as well, because I'm looking at the column and then I can just compare those, right? And then this takes advantage of that speed, so this is relatively fast. Okay.
Well, so let's think about this versus great expectations, which we were talking about earlier. So I think this has been a really interesting example of something in Pandas. They're talking in chat right now about SQL and how hard this is to do in SQL. But great expectations has basically built the interface between, it sounds like, SQL and data validation, right? Effectively, because they allow you to do it in database. Is that correct?
That's whoever's bringing that up. That's a good point. So great expectations. They, if you look at the expectations, they have a table, right? And they'll say like, hey, this is compatible for Pandas, SQL, or in Spark, right? So there are times when you'll see that the SQL is missing, right? Spark is missing, because these are operations that are hard. So something like a distribution I would expect to be available in SQL Alchemy, but there's also a lot of stuff that will be like unsupported in SQL Alchemy. The second thing is that you can have operations that don't make sense. I mean, like make less sense, right? Like for example, like going back to the median, right? I think you can have, or sorry, this is a good example. No, there's no index in Spark. That's not doable at all. So for example, this column median to be in between. In Pandas, medians are cheap to get. In Spark, they're a bit harder, right? Because if I know like 10 numbers and you know 10 numbers, we can get the mean if I get my mean and your mean and we combine those two means. But can we get the medians of our two numbers if I report to you something and you report to me something? You can't, right? Because the worst case is like all your 10 values are actually higher than mine, right?
Right.
So
Yeah.
So you can't do that. So now that means that we need to exchange numbers in some way. So we need to exchange information. So I need to give you like a list of like some of my numbers, and then you give me a list of some of yours. So we actually change, and then we kind of estimate. But in order to estimate the precise one, we need the full exchange and the full sort. right?
It's so interesting seeing, I think, the drawbacks of distributed computing in this sense too. And by the way, too, when I brought that up about SQL, I had forgotten that they were using SQL Alchemy. They had not done their own thing. Obviously, I think that would be just a whole other undertaking. So
Yeah, they have some sort of abstraction where like I
yeah,
can write an expectation once, and then it's like applied on the different engines. For example, it's like broken down into like blocks, like at least like Lego blocks, where like this is how you get a mean in SQL, and this is
right.
how you get a standard deviation in SQL, and then like this is how you do it in Pandas and Spark and Pandas, and then once you have those, it's like, okay, how do I get the normal check for normality, right? Then
Right.
I use those building blocks and I construct them. So yes, I mean it's probably convoluted, but yes, you can
Mm-hmm.
piece it together in SQL. I wanna just a bit of story time though. I had a boss who, man, this kind of public to be saying this, but no, I won't say what company I was
Mm-hmm.
in, but and it's not necessarily a negative thing either, but I remember I had a boss who was all SQL, and this guy implemented a clustering algorithm in SQL. He was like, "Don't worry, guys, I got this." And like 1 week later, 800 lines of SQL code. He's like, "See, guys,
Easy.
easy, easy." We're like, "No, man, that's not easy. How can we maintain that?"
Oh
Like,
yeah.
I,
Maintaining
I,
it
can't,
is the nightmare.
I can't even understand what he did. It was crazy. It's also
Yeah.
like a lot of skill, like crazy. Um, so the last thing to show about Pandera here is the decorator usage. So this is just directly from their documentation. But what I can do is like I have this this check input decorator, and now if I have a function like this, I can say, hey, check the input here. And then the first argument has to be the data frame. And now when it comes in, I'm checking the data frame. And then I also have check output similarly to check the return type. And then if it doesn't make sense to stack them together, right? Like check input, check output. So
Mm-hmm.
what they did is they exposed check IO. And check IO is like the in schema and then the out schema. So actually, this is really nice because I can define all of my schema like this in some other file, right? Imagine it's in some other file, and you just say like from other file, import in schema, out schema,
Mm-hmm.
like that kind of thing. And then you just like use the check IO decorator and apply it. It's very non-invasive, like Prefect, right?
Right.
Um,
Kind of like
so
setting it up
that
and then writing it in line, with your, so it doesn't like impede the code that you're actually writing. Very similar to a prefect value prop.
yeah. Um,
Interesting.
so I am like we're already like 5 minutes to the hour. I do have stuff to share. But let's think about this. I don't know, how do you want to do it? Do you want to see Prefect 1 or do you want to see Orion directly?
Yeah, let's try to go right to two, right to prefect two, right to Orion. I think that might be interesting. We can go maybe like a little over two, and then you can always just publish
Part 2.
your example.
Part 2.
Yeah,
Next week, part 2.
we'll do part two next week. Yeah, I think we'll definitely get it on GitHub, of course. But yeah, let's I mean, not to challenge your skills. I know that we're still very early on in the Orion life cycle, but would love to see it.
Yeah, so this I haven't actually tested this, but some people have asked, "Hey, how do I use like like, okay, so in community there's people asking, how do I use data validation prefect? So we have that task if you want to do it in prefect 1. But if you like wanted to use something like Pandera, I think it's pretty easy, right? It's pretty standard what you'd expect. So we say from prefect import flow task, and this is now Orion code, and we have prefect, and let's say this is just a validate data frame.
Will you zoom in a little too?
Oh yeah, you're right.
Perfect. Thank you.
Okay, so let's say this is you just validate a data frame, and this takes in a pandas data frame. You would just import your guys, right? Like import pandas spd, import Pandera spa, Pandera spa, and what I would honestly do is you can define your validators like out here. So I'm gonna pull. Yeah, I'm gonna pull these guys. Really new data. We'll toggle between these. We'll show like what happens if it fails,
Mhm.
and we will get some validation that fails. So this one passes. No, this is a good one actually. So we have we defined the data frame schema out here. So this is what I'm saying. Like this one, you could import it if it were defined in some other file, and then I will just take this out. So this should work, and then we can do schema.validate baseline, and this actually returns a data frame. So we can do it, or we can do something like this, and I'll leave this as commented. And now in your flow, uh, let's just pretend I'm getting my data from somewhere else. So I'll just make a task to like get data, and this is takes in nothing and returns the CSV. I mean part K, or actually I think I can just part K. Okay, so we have our flow, and then let's call this the validation flow, and this one will take in get data. And from there, we can just say validate data frame. And it should be as simple as this. And what I hope is that if we do flow, if we call this validation flow, we will actually see success. And then we're going to replace it with the new data, and we'll see how it takes failure, right?
Right.
So here we have our validation flow, and um, we can just run this. Oh no. Okay. I'm just in the wrong directory here. Let me just save this in my demos folder.
I'm gonna move you up too, so you're not. I'm cutting you off right now, but I'll do that real quick.
Cutting me off? No.
I'm cutting your bottom. I'm cutting. No. The bottom of the screen. I meant. There we go. So
Okay.
we can see that.
Okay, so we have validation flow now in this directory, and we can run it. I don't have pandas. And Pandera, actually, I probably don't have.
Mm.
Oh, this is actually wrong. Yeah. Okay. And we should see Orion in action. Oh no. Orion. Oh no. Did I do something? Oh, there we go. Okay, Orion's good. So we have Orion. And yeah, I can go in the UI just to show what it would look like.
Yeah, which is so awesome that we can just.
Yeah, so I'm gonna do prefect Orion start, and we'll go to our UI. So in our UI, we should see. Man, I actually ran a lot of stuff today. Oh, I had a schedule. I think it just ran all of those like runs when
Oh,
that's why it
that's
was
what
so
was
slow.
going on.
Yeah,
Okay.
yeah.
Okay.
That's why it was
funny.
slow.
That's
Yeah,
funny.
it just ran all of those guys. Yeah. So now we have our radar plot. As expected, we got our data, we passed it, we validated, it's all good. Right. So if you wanted to put this on some schedule, you could just use a deployment for that, get data from some place, like you're querying it from a SQL database or reading it from a data lake, and then you can run your validation through it.
Nice. This is the ultimate schedule, like scheduling your validation. That is so awesome. Sorry, I cut you off.
No. Yeah, exactly, right. Like if you want, and right, like we're the guys who can send you the notification, right? So if you can pair your like Pandera doesn't have notifications. You still need
Right.
Prefect, right? Yeah. So now the what we're curious about is if we pass in the new date, and this is actually new to me, so I don't know what's gonna happen. But my no, we want this here, and we will run it. Take this out, and we'll see what's gonna happen when our validation fails, right? Okay, so we got the error,
It
and
returns some results too. It looks like.
yeah, it did. I hope I'm not 100% sure we'll see it in the UI. I hope so, because it's like in the traceback, right? So if I go to this failed run here, I should be able to see.
Look at
Damn!
that.
Look at that!
That's
Look at
nice.
that! Yeah, that's nice. So we have our failure. So actually, we can pass the whole data frame like what we saw earlier. Like we could do stuff like where's this? We have a try except somewhere here where we got the failure case. This this guy. We could use like this instead, and then we could print that report as a
Right.
data frame instead. Um, so also, oh yeah, we have to see radar. So radar shows that we failed, right? We got the data and then the validation failed. So what we can do is like we can check like the state of that, like if we wanted to. So we can say like, hey, if this like, uh, I think it's dot state. I'm not 100%, but I think it's dot state, and then you can say that is failed. And now because of Orion's dynamicism, you can do something. Maybe we'll try it. Let's just try it and we'll see what happens. And if it fails, then we'll just end there. So we'll do this. No, we can just do something like this. If and then from there, we can just have another task that just let's say this was a reporting error reporting task, and this took in nothing, and it printed. We don't really capture the prints though right now, so I'd have to get the prefect logger. I think um, uh, I think it's just like get run logger. I hope that works, and we can say logger get run logger, and then from there logger.info still failed, and so now what we can do is we can submit this task dynamically, and we can call the error reporting if this validate fails, and we can give that a shot. If this doesn't work, then I'll have to go to docs. That actually, I believe, worked. We can go to the Orion UI, pulling the Orion UI here, and our latest run failed as well. And we have these two failed tasks. Oh no, we don't. It did not. It did not material. Did I not even get the logs? If validate, I'm gonna try one more thing. So we're gonna just do this and then val dot.
What are you returning up there in that log task?
Oh, nothing. It'll just throw.
Okay.
Yeah. Um. I think I think this is good. So no, it didn't seem to print. Um. Yeah, I don't know what. Oh, there is no attribute state. Really. Let me see if I can figure this out in like a minute. If not, then we'll just we can just end this stream.
Yeah, we'll make it a part 2.
Yeah. But I'm opening the docs here.
Yeah.
And I'm just gonna look for how to get the state. Maybe we can go here. And if the chat knows, please let me know.
I'm just gonna throw a link to docs too in chat.
Okay, if
Anna says get_state.
Oh, but I thought this was an alias just for get state, but we can try that. And if you know what, if this doesn't work, we're going to the result. Yeah, I don't think that works. So here's what we'll do. We'll just say val.result, and I'm gonna just say is instance,
She
and then
said
say yeah.
wait is missing before that.
Oh, okay. I think this should work. No, also. No, also. Where should I like dot? I think Anna's suggesting like this then. Still. Oh, you know what? Maybe I have to do. Maybe that Pandera, that error is not a native Python. Let me get our this guy, and we'll do this. Okay, we're done here. That's good enough. Part two,
Nice.
part two, part two.
Yeah, nice try. Nice try. We'll do that in part two. Awesome. No, that was that was really funny. Anything you want to wrap up with on data validation? This was a really fun session.
No. Don't have anything. Oh, I mean, there. I just want to say we didn't get to this stream, but there's something really cool that you can do where you can actually use the prefect mapping with validation. And I'll just type out some pseudocode for that. Like what you can do is, if this were prefect one, I'll just activate prefect one. So this is what I was going to show today, and I'll just give a brief outline. What you can do is if you had, maybe I want to keep a bunch of this. So if I had this, what you can do is think of your get data, and you have a list of Parquet files, right? So this actually returns some kind of list. What you can do is you map over the validation of each one of these, or maybe even the same guy. You like map over him, and you do different validations in front. I mean, not really. That's not really a good use case, but this you have like I have two data frames, and now I have a validate data frame that takes in one and runs the schema on it. What you can do in prefect one that I've been curious about. I mean, I think you can do this. Is you can have um, your DFs get data, and then you can do validate data frame dot map. And let's say this guy took in the schema dot map, and then you map over your data frame and your schema. Um, this is treat schema like a list also, right? So if you had get schema, right? And now what this does is like, hey, if you have a really big data frame, like when we first talked about validation, we talked about geography. So now let's say you partition your data. I mean, yeah, you partition your data by region, and then you have like region specific schema. You can now parallelize the validation of those. Like you say, hey, this is the California data frame, and this is the main data frame and the Florida data frame. And then you have different schemas for each of those, and then you map over your DAS executor, and then you can scale your validation that way, especially if you're doing stuff like distributions also.
Yeah, so you're not limited by pandas anymore, right? Effectively.
Yeah. And then you can use the DAS executor on top of that, and then you scale out, right?
Cool.
Yeah. So yeah, that's it I have. Yeah. Thank you
Appreciate the
everyone
main
for joining.
shout out. Appreciate the main shout out for sure.
Sure.
Yeah. Oh, yeah. Thank you, Kevin, very much for coming on. This was really cool. Yeah, it looks like next week too, Alex Street is going to give a little demo on Great Expectations. So on 3/29. I think that's next Tuesday. So everyone join in for that. I think that's on the Great Expectations community call. And then Kevin, you're gonna put this in GitHub and then post it to the community. Is that right?
I'll put the notebook on GitHub. Yeah.
Cool.
Yeah.
Okay. All right. Thank you very much. All right. Cool. Thank you for coming on, Kevin.
Thank you.
See you guys.
All right. Bye.